And so 19 things that you're not going to be tested on. So if we want to show that this is monotonically decreasing and positive, we want to show that basically this thing is the derivative is negative, right? So if I found the derivative, I would have to take the derivative natural log of n over n squared. So if I want to take that derivative, well, I have to use a quotient rule. So I'm going to get n squared times the derivative of natural log of n, which is 1 over n, minus the natural log of n, times the derivative of n squared, which is 2n, all over n squared, aka n to the fourth. I can simplify this a little bit, right? N squared times 1 over n is n, minus 2n times the natural log of n, all over n to the fourth power. Right, so this is what our derivative is going to equal. So we want to show that this is a monotonically decreasing positive function whenever n is greater than 2, right? So for starters, let's try to find our critical values, right? So when would this function be equal to 0, right? So that's going to occur when n minus 2n times the natural log of n, that's a weird L, is equal to 0. So I can do a couple of things. I can factor out an n here. So I'm going to get 1 minus 2 natural log of n equals 0. So this is going to occur when n is 0. That would be a critical value. Or when, this is very, very bad spacing, or when 1 minus 2 natural log of n is 0. This is going to equal 1, 2 natural log of n, aka natural log of n equals 1/2. So this would be n equals e to the 1/2 power. These would be our two critical values. Right, so we thought about what happens there, right? So 0, which we really don't have to think about because the natural log of n is not defined when n is 0. So 0 isn't really a critical value, but e to the 1/2 power is. E to the 1/2, aka the square root of e, is like the square root of 2.718. Let me get a little bit of calculator action for you. So square root of e gives us roughly 1.64. So let's call it basically 1.65-ish. All right, so that's our critical value. So if we chose anything between 0 and 1.65, like, I don't know, n is equal to 1, well, we don't have to plug it in to the bottom because the bottom is n to the fourth power, so it's positive. So if I looked at my numerator, I'm going to get, since it's n, 1 minus 2 natural log of n. If I plugged in n was equal to 1, I'm getting 1 minus, or 1 times, 1 minus 2 natural log of 1. Right, so that's going to be 1 times 1 minus 0. Right, so that's going to be positive, right? So this means that f of x is increasing from 0 to whatever that value is, e to the 1/2. If I picked some value of n that's greater than that, like 2, right? So if I had 2, 1 minus 2 natural log of 2, right? So the natural log of 2 is about 6.31. So I'm going to get, where did it go? Somewhere, there we go. 1.2 times 0.6931. So 2 times 0.6931 is bigger than 1, right? This is like 1.4-ish, 1 minus 1.4-ish. This is going to be negative. 2 times a negative is still going to be negative. So this means f of x, or I should say a of n, rather, is decreasing. So what do we just show? Well, we show that between 0, remember, n is a positive whole number, right? Because it's a sequence. So when n is equal to 1, well, it's positive or it's increasing. Whenever n is greater than 1, 2, 3, 4, 5, it's decreasing. So we show the decreasing part about it. The positive part is going to be easy, right? Because if I square n, it's going to be positive. Natural log of any number greater than 2 is also positive. Positive over positive. This thing is positive, right? So we've just shown that this thing is decreasing and positive for all values of n greater than 2.